In this video, we're going to be learning how to use the current divider and voltage divider equations to solve two circuits. Now, the current divider equation is used whenever you have parallel elements. So, for example, if you have some circuit that looks like this, with some known current going into it. The current in any of these, it could be 2, 3, 1,000, however many resistors are in parallel, is equal to I times the equivalent resistance of that parallel series, or of those parallel elements, divided by the resistance that you're interested in. Now, for the voltage divider equation, this is used when a voltage is across a series of elements. So if you have some voltage V, and you have a series of elements, so 1, 2, 3, the voltage divider equation says that the voltage across any of those resistors is equal to the source voltage times the particular resistor divided by the equivalent resistance, which is going to be in series. So I'll just series and parallel, highlight those two. So let's try a couple of good examples which each use the voltage and current divider equations. So in this first example, we're asked to find the unknown current I0 and the unknown voltage V0. So the current flowing through this 24 ohm resistor and the voltage across this 30 ohm resistor. So the first thing we're going to look at is the equivalent resistance of this large circuit, because the current is flowing into this circuit and they are parallel elements. So I-24, the current flowing through the 24 ohm resistor, is equal to I times R equivalent divided by R. And that R is 24. I'll just write 24 so I remember. R equivalent in this case is going to be the first branch, 36 plus 44 ohms, which is in parallel with a 10 ohm resistor, in parallel with 40 plus 10 plus 30, which is in parallel with finally 24. (36 plus 44 is 80. (40 plus 10 plus 30 is 80 as well. 1 on 24. Take the inverse. And if we get our calculator, 1 divided by 80 plus 1 divided by 10 plus 1 divided by 80 plus 1 divided by 24, inverse. Our equivalent resistance of this circuit is 6 ohms. Now we can solve for our current. So I-24 is equal to 8 amps, the current flowing into the circuit, times 6 ohms, the equivalent resistance, divided by 24 ohms. This is going to be equal to 8 divided by 4, which is 2 amps. All right, so we found the first part of our question. Now we need to know the unknown voltage V0. Now V0 we can solve for by looking at this series of resistors and determining this voltage, which is the same voltage across here. That voltage V we can determine with Ohm's law. V is equal to IR. The current we just found to be 2 amps, and that resistance is 24 ohms. So that's 48 volts. Now we can apply the voltage divider equation. Voltage across 30 is equal to V times R divided by R equivalent. Now this isn't the same R equivalent that we found earlier. It's the yellow highlighted R equivalent. It's the series equivalence. So this is equal to 48 volts times 30 ohms. And the series equivalent resistance is going to be 40 plus 10 plus 30. So that's 80 ohms. So the voltage across the 30 ohm resistor, 48 times 30 divided by 80, that is 18 volts. All right, let's try one more example. In this example, we're asked to find the unknown voltage V0 right here, and then determine the current in the 30 ohm resistor. All right, so in order to do that, we're going to look at this circuit, find the equivalent resistance of this, because this equivalent resistance that I've highlighted is in series with this 40 ohm and this 70 ohm. All right, so our equivalent is 20 parallel in with 30, parallel with 50 plus 10. 1 on 20 plus 1 on 30 plus 1 on 60. Inverse. Inverse. That equivalent resistance is 10 ohms. So now voltage across 40 is equal to the voltage source times R on R equivalent. The source is 60 volts. Resistor is 40. But this R equivalent isn't the same R equivalent that we use. Remember, for voltage divider equation, we have to use a series of elements. What we found here, this first R equivalent, was the equivalent resistance of this circuit. But in our voltage divider equation, this equivalent resistance is the series equivalent. So it's going to be 40 plus the yellow equivalent resistance of 10 ohms that we just found, plus the 70. So 40 plus 10 plus 70 is 120 ohms. So this is going to be equal to 20 volts. So 20 volts across the 40 ohm resistor. Now we want to know the current in the 30 ohm resistor. So how do we find the current going into this circuit from this voltage source? Well, we know the voltage here now, and we know the resistance, so we can use Ohm's law. So do a different color. The current flowing into here, I'll call it I naught. I naught is equal to, what we want is I30. That's equal to I naught times R equivalent divided by R. The equivalent resistance in this case is going to be the yellow highlighted region that we actually already found. That's 10 ohms. And R is 30. So I naught is equal to voltage divided by resistance, which is 20 volts divided by 40 ohms. Is equal to half an amp. So I30 is going to be equal to 0.5 amps times 10 ohms divided by 30 ohms. It's going to be equal to 0.667 amps, or 667 milliamps. So that's it for this video. Please comment down below any topics that you'd be interested in hearing about. Please like, share, and subscribe to this channel for more content like this. And be sure to check out the playlist I have on DC circuits and circuit analysis. Thank you, and have a great day.